charts. One is called C chart. The other one is called U chart. Make a note. When you can do C chart is known as number of defect chart. You can do it when your subgroup size is 1. When your subgroup size is more than 1, then you have to do a U chart. U chart is called number of defect per unit chart. So guys, can you tell me in the first sample what is the subgroup size?
4.
कहाँ से 4 कहाँ दिखाया तेरे को?
Sorry, I spoke about the previous example. Sorry.
No. Now we have come to this C10 and C11. In the first subgroup, what is the sample size?
10, sir.
Lovely. In the fifth subgroup, what is the sample size?
22.
Do you understand? So now you tell me, it is a data on defect or data on defectives? Defects. So which control chart you will follow?
C chart, sir.
No. So when you can do C chart?
Only a single group is 1.
Subgroup size is 1. Here subgroup size is more than 1. So you have to perform a U chart. Okay?
Yes.
Okay, do it. So go to stat. Come to control chart. Select attribute charts. See, there is a U chart somewhere.
U chart diagnostic and U.
No, U chart. Plain U.
U.
Click that. So the variable means defects. Subgroup size means here orders inspected. Click U chart options. Test all the 4 assignable causes. Click OK and OK. Look at the limit. Now you see the very interesting thing. The control limits are broken line. Can you tell me why the control limits are broken line?
Variable lot size.
Because your sample size was different, right? So when sample size is different in attribute chart, the control limits will be broken lines. Fine. And did you observe in this chart there are 2 samples which has fallen outside lower control limit and it has been marked as red?
Yes, sir.
Okay. Now, so what does it indicate? Anything goes out of control?
Assignable causes.
Assignable cause. So what assignable cause produces less defect? It is number of defect, na?
Yes, sir.
So which assignable cause produces less defect? Assignable means something wrong?
Yes.
So which wrong thing produces less defect? Okay, I'll give you the first clue. New inspector. Possible?
Yes.
Now you tell me the next one.
Change in process.
Change in inspection method.
Yeah.
Sometimes you might not have followed the actual manufacturing process. You might have used some imported material for a couple of days, because of which the defects are pretty less, right?
Yeah. Awesome.
So again, it is an assignable cause. Okay, clear? Go to the third data. Okay, can you tell me it is a data on defect or defectives?
Defectives.
Defectives.
Defectives. Come on, error is defect, na?
Defects.
It is a data on defect. So which control chart you will use it now?
Chart.
U chart, because the subgroup size is more than 1, correct? So
Yeah.
quickly do a U chart practice. Copy only B and C. So is it problematic?
Yes.
Anybody has any problem in doing this chart? Okay. So silence is a good answer. Go to the example. Go to Excel back. Next one you take. Okay. This this has some difficulty in analysis. Actually, I did not give the data correctly. Go to sheet 5. It's my mistake. Can you tell me? You understand what is this data? This data is very interesting. Number of complaints you are receiving on a day and number of them you are resolving in a day. Somebody told me in the last phase you receive some calls in a day and you close them in a day. You gave me that example, na? One of you? Are you able to hear me?
Yes, sir. We can.
Yes, sir.
Yes, sir, we can.
Okay, great. So can you tell me it is a data on defect or defectives?
Defectives.
Defectives, because it is not about defect, it is about those incidences which are reported, how many of them you could resolve. Now make a note. If you have a control chart on defectives, you can do P chart or NP chart. P chart when subgroup size is constant. Sorry, I just told the reverse thing. NP chart when subgroup size is constant. P chart when subgroup size is not constant, or even for constant also you can do. Here, which column is the subgroup size, boss?
Complaints.
Oh, lovely. So you see, it is not constant, right? Manish, copy B and C and put it in Minitab.
Sir, one second, just I'm noting the
subgroup.
Yeah, do it.
For
do it.
P chart, you have P chart subgroup is not constant. You see.
Not constant, but you can do it for constant also. But NP chart you can perform only when it is constant. So go to stat, control chart, attribute chart, P chart. Okay, now variable is, which one is the variable now? Can you tell me?
Complaints.
Result.
The result.
Very good. So happy. Subgroup size is complaints. Click P chart options. Click test. Select all the 4. Click OK and OK. So you get the broken line chart. You got the broken line chart because of the reason the subgroup size is not constant. Okay.
Yeah.
No difficulty. Please go to the next data. So now you see, I have got a data how many contracts I am processing, and each contract is undergoing how many revisions before acceptance by the customer. Okay? Is the data clear?
Yes.
Can you tell me what control chart you will do in this case?
Effects.
Very good. Which control chart?
P.
Sorry? Okay. In defects, which are the options you have?
C chart and U chart.
C chart and U chart.
Lovely. Now, what is the subgroup size here?
Oh, it's more than 1.
Here, the subgroup size is 1 because I am giving you the data of each contract. Okay?
Okay, it is
What contract?
2. Okay.
Arey Baba, contract number 2.
Okay.
Okay?
Yes.
It is not number of contracts. So copy the column
C chart.
So it is the case of C chart. So copy the column C. Go back to Minitab. So go to stat, control chart, attribute chart, C chart. Variable is revisions. You know, you understand now Minitab screen? This Minitab fellow did not even bother to ask you subgroup size. Will you remember this? Because C chart is a by default subgroup size 1 chart, okay? Please never do a C chart when your subgroup size is greater than 1. Okay? Why I am telling so much? Because I see people do wrong analysis and it's very difficult to digest, you know, because you know a little bit of statistics. So now you don't see any broken line. So how many revisions are allowed? Anything from 0 to 9. So since it is defect cannot take fractional number, you know now. So either it is 9 revisions or it is 10 revisions. So anything greater than 9 will be an assignable cause. Clear?
Yes, sir.
Great. Go to the next one.
How do you define this subgroup, sir?
And that you have to understand by the looking at the data. Okay, Manish, which company you work?
HP, sir.
Sorry?
HP.
HP. And
HPI.
which process we are working?
Went to inventory, sir.
Okay. You are looking after stores, inventory management, right?
Not stores, sir. Inventory planning and control.
Planning and control.
Yeah.
Okay. Tell me, can I have a data like this? You write down there on this screen. It is Excel now. Type in E, month. Just, and next you write number of stock out. Arey Baba, next to month you type number of stock out. You understand?
Yeah.
Number of stock out incidents. Correct na?
Yes, sir.
Boss, tell me which control chart you will do.
So it is each month. So subgroup will be one. And number of stock outs will be variable. So will be so C chart.
All of you agree with Manish? See, basically, what is the, you still again remember, I will give you one more time repeating myself. This is how I taught you in measure phase. What is the differentiation between defect and defectives? You remember the first thing I defined, something called unit.
Yeah.
Boss, in this data, what is the unit?
It's a number of numbers.
No.
Numbers.
No. This is the problem with all of you people. You people forget things. Okay, Manish, in the previous example, contract and revision, what is the unit? Data is collected on what? I think you have forgotten. Okay, so you can revise my measure phase notes. In the previous example, the unit was, yeah, Neeraj, tell me.
Defects was the unit in previous example.
No. I think you forgot. You have gone back to your original status, all of you, successfully.
Contract is
Contract was the unit. In this data of month and number of stock out incidents, what is the unit?
Stock out.
Month, yeah. Unit is month. In a month, how many stock out incidents can happen?
Many number of stock out.
Main.
It is 0 to n or 0 to infinity?
0 to n.
This is the problem of understanding now. You are not understanding.
So
In your
defects can
mobile
be
phone,
infinite.
in a day, how many messages can come? 0 to n or 0 to infinity?
0 to infinity.
Infinity.
Then why in Manish's case it will be 0 to n?
It will be infinity.
0 to infinity. But it will never become infinity, na?
Yeah.
Yeah,
So-
practically no.
Practically it is not possible, but theoretically it is 0 to infinity, correct?
Yeah.
If it is 0 to n, it is a data of defect or defectives?
Up to L it is defective.
Defective.
Very good. 0 to infinity? Defect.
Defects.
So whenever I am giving you a data, you have to first make your understanding very clear. This data speaks about what? The unit of the data is, the unit what we are talking here is a month, because I have to first fix the unit. For discrete data, the unit has to be specified, otherwise it makes no sense. Neeraj, if I ask you, how much money you spent? Is the question is very good, very clear question?
Yes, sir.
Yeah, come on here. How can you answer this question? Because the question is incomplete.
Yes, yes. You have to give some time frame.
So I have not defined the unit.
Mm-hmm.
So if I ask how much money you spent in a day, you can answer. How much money you spent in a week, you can answer. How much money you spent in a month, you can answer, right?
Correct, sir.
So simple thing, you're getting confused. And that also on the last day of your training.
The defectives is clear, sir. Only that subgroup, because for example, for SPC, suppose if you are doing hourly inspection, so we take 5 samples. So we call it as every 1 hour that there's a subgroup.
No, subgroup of size 5.
Yeah. Okay.
Now you are working in which company?
Siemens Gamesa.
Siemens. Oh, you are Balu na?
Yes, yes.
Okay. Now, so do you have a actual application of subgroup more than one inspection in your area of business?
Not directly, but our suppliers, they will do this kind of.
Okay, so can you give me an example of a supplier and its process?
Yeah, cable manufacturing process.
So what they do?
So they will be taking sample of 5 every 1 hour.
So what is the name of the process, sir?
Like conductor resistance.
Okay, resistance checking.
Yes.
So they will take 5,
Yes.
and every hour they will take 5.
Yes.
So when you talk about this kind of a data, the subgroup size is 5,
Yes.
and interval of inspection is 1 hour.
Yes.
So in this kind of data, what cannot change? The interval should not change, and the subgroup size should not change, right?
Yes.
Okay. Go to sheet 7, Manish. Okay, now can you tell me this data you see? Every month, let me explain you this data. Every month I am surveying 50 customers about CSAT, okay? And the CSAT customer can give 1, 2, 3, 4 different scores. 3 and 4 indicate satisfaction. 1 and 2 indicate dissatisfaction. So I'm counting how many of them are giving me 3 or 4 score. Is the data clear?
Yes, sir.
So tell me which control chart.
It's basically defect.
Is it a data on defect or defectives?
Defectives.
Defects.
Defectives.
Effective, sir. NP chart, sir.
Defective.
NP chart. Very good. NP chart, because subgroup size is constant.
Constant.
You are asking only 50 customers. So maximum how many customers will be satisfied?
50.
50. So it is a data on defectives, boss. Why you are getting confused? So copy C and D. Go to stat, select control chart, attribute chart, NP chart, put 1 by. Okay, which is the variable? Variable is 3 and 4 score. Subgroup size is sample size. Hey, type subgroup size 50. Okay. This is also fine. No, nothing, no problem. Go to NP chart option, click test, select first 4 test. Click OK. I hope it will do. Done?
Yes.
So no assignable cause, but worrying factor is number of satisfied customers are reducing, right?
Yeah.
This should not happen before your increment month, right? Okay, go to the next data. Now tell me, what is this data? Sales value on a daily basis. Yes or no?
Yeah.
Which control chart you will do?
Each also.
You know, this is what is called harassment. This is what is called ragging when you are in college. I am ragging you people now. Which control chart? Yeah, yes. I could not hear the answer properly. Milan, I could not hear anything.
Yeah, I chart, sir.
Very good, correct answer. Because sales value is a continuous data. So you have to do eye chart. And Milan, can you tell me the procedure for doing eye chart?
Yes, sir. I will do.
बताओ लेक्चर दो मेरे को. Tell me what you do first.
State.
अरे यार, first you tell me what I should do. मिलन तुम भूल गया. तो for doing eye chart, what is the first thing you should do?
I can tell, sir. I can tell, sir. Sorry.
बोलो.
Yeah, first you have to check normality.
Very good. And then
Then we have to check if it is normal, then we can go ahead with the eye chart.
very good. If it is not normal,
Then we have to check the Johnson transformation.
very
And
good.
after Johnson transformation, if it is okay, normal,
Then you
then
can do
we can
eye chart of the transformed data.
transform data. Yes,
Very good. If it is not transformed, then which chart you will do?
we have to do run chart.
Very good. Thank you very much. My sincere request is please remember all these steps till Saturday. So this is just a confused one. I just put a continuous data in between discrete data. Okay, go to sheet 9. Okay, now you understand this data? I am collecting data analyst wise, number of jobs bid and number of jobs won individually. So which control chart?
Effectives.
Chart का नाम बताओ.
P chart.
T chart.
P chart. So एक P chart बनाइए Manishri. No. Scroll down. Jobs 1 is your variable and jobs bid is your subgroup size. No, you put the same thing both the places.
Sorry.
Lovely. Options are already taken, I believe.
Yeah.
Okay. Fine. So you can do. So last data set, let me see what is that. Is it of any use? Oh, last data set I will not touch now. I'll touch it now. Okay, so we have analyzed all the data. So basically, I gave you how to work on P chart, NP chart, C chart and U chart. You know, This is doing the control chart is not very difficult job because the process of doing chart remains same. You have to, but what is difficult? The most difficult thing is how to collect data meaningfully from the process. You have to define the variable very, very smartly, collect data, and then you do the right chart. In your training material, we have given you a slide where it is very clearly written when to do individual control chart, when to do X bar R chart, when to do P chart, when to do NP chart, when to do C chart, and when to do U chart. You have to go through that and remember it. Is this fine?
Yes, sir.
Yes.
Okay, no problem. Okay, so Manish, you stop connecting, and I request only to connect your machine with the same data. I'll show you something else now,
Yes, sir.
please.
Sharing, sir.
Yeah, yes, no problem. Okay, now what I'll teach you is called the last analysis of the day, which is called before after analysis. So copy the column B and C and put it in Minitab. You have not taken the whole data. B and column C, that is more important for me.
Okay.
Okay. Paste it here. You have pasted it wrong place. Control Z. Paste it below. So you call it TAT. First one you call it TAT. Second one you call it process. So guys, this is a very standard deal, you know. For every Six Sigma project, you have some data collected in the measure phase as a Sigma rating for measure, and then you will collect again data on your CTQ after your improve phase is over. Are you clear? And then this is one way of putting data. You have put the data one below the other. So I just want to tell you what are the most must-do slides for your control phase, just to show that things have improved. Okay, go to graph. Select box plot. With groups. Select that. Categorical variable, you select process. Click OK. So, does it show very clearly that TAT has improved after process change?
Yes, sir.
Yes, sir.
All of you could do this. So this is one very good presentation material, okay? All of you should know how to do a box plot before and after. There is one more before after you can do. Go to graph. Select interval plot. Okay, with groups. Again, you do the same thing, TAT here and process there. Click OK. This also will look very nice. You get my point. You can put on this graph by editing the value of mean and the value of the boundaries. This I taught you last time. I hope you remember this. Okay.
Yes.
Okay, done. So this is done. Okay. Okay, you want to do it? Edit graph. Select add items. Data labels. Select interval midpoint. Interval midpoint Y value level. Click Y value level and click mean Y value level. Click OK and OK.
Huh?
Oh, you have put something else. Individual values you have put. Okay, add item, data labels. Data labels, click individual data and remove and click none. Okay, click OK now. And okay. So now you see it looks much better.
Yeah.
So this also can go as a good presentation, right? So it
Yes.
clearly tells that mean has reduced from 4.17 to 1.8 something, right? Okay, go to graph. Select histogram. Select with fit and groups. Click OK. Graph variable is stat. Categorical variable is process. Click OK. So the advantage of this is it clearly tells you what is the value of mean, what is the value of standard deviation before and after. Fine?
Yes, sir.
Okay, go to stat. Hey, class, are you able to do all these things?
Yes.
sir.
Because I'm going little fast, I don't know why. Because I'm thinking you are able to do it. So stat, basic statistics, display descriptive statistics, select at, by variable select process, click statistics, remove AC of mean, remove minimum maximum, remove n missing non missing, select n total, n total, that is above below n missing non missing.
Yeah.
Click OK and OK. So if you are looking for some test stat, it is here. You know, all the statistics it will show you. Whether mean has changed, standard deviation has changed, Q1 has changed, median has changed, Q3 has changed. So these are very helpful, you know, as a summary statistics to showcase your result, right?
Yes, sir.
Now some serious action. Go to stat, select quality tools, select capability analysis, multiple variable normal. Variable is stat, subgroup size is 1. Hey, not that one. Subgroup size is 1. By variable, click inside process and lower spec you put a value. Just put a number now.
Yeah. Just
Okay,
started one.
click graph. Remove that histogram fellow. Click OK. And OK. So now, where is the graph? Scroll down. So this is the problem. Before data was normal, after data is not normal. Sorry, ulta bol de. Before data was not normal, after data is normal. So now you know I can do a two variance test, but I cannot do a 2T test, right? Are you okay with me?
Yes, sir.
Okay,
Yes,
let us do a two variance test. Go to stat. Go to quality tools. Sorry, basic statistics. I forgot basic statistics. You can find two variances. Okay, sample you click. Sample you click inside TAT you take. Sample IDs are in process. Click OK. So what is the p-value of Leven's test? 0.4.
0.4.
So what is the conclusion, madam?
we have to reject the hypothesis. So the mean of
Hey,
both.
hey.
Variances
So
are
p-value
equal.
is p-value
sorry.
is less than 0.05 or more than 0.05.
It's more than 0.05.
So what is your decision?
Variance is not. Variance is
First, you tell
significant.
me the decision about H naught.
We have to accept H naught.
You have to accept H naught. Now, you know it is not coming out of your mouth, right? It is not coming out because some problem. Either you have forgotten or you are confused. So this is not a good sign, right? How can you forget so easily? So anyway, so accept H naught. That means variances are equal, right?
Yes.
So variance did not change significantly. Fair enough? Now let us do a Kruskal-Wallis test. Go to stat. Select non-parametric. You forgot everything. Me. Select non-parametric. You'll find Kruskal-Wallis. Select that. Factor is your process. Click OK. How much is the p-value?
0.
So accept H naught or reject H naught?
Accept H naught.
My God.
Sorry, reject H naught.
Reject H naught. That means
Yeah.
medians are not equal. So after median is significantly lower than the before median. Fine. So the process improvement is significant. Now you can calculate the sigma rating of the after data. Fine. You have already computed sigma rating of before data. Then both the report you can show and you can tell, look, my sigma rating has improved from this value to that value. Fair enough? Do all of you understand?
Yes, sir.
Yes, sir.
Good. There was one data file in test of hypothesis I have sent. You can open the data file. Let me check for one data there. I thought I have given you one data. TOH. Yes, so there was one file called process improvement. Where it is gone? Now come to the right hand side. Process improvement. You know, okay, copy this data, loss percentage and status. Copy this data. Put it in Minitab. So you can practice. I have given you one more set of data, right? This is for all of you practice. Umi, can you just do a normality test of this data? You forgot. You are so quick to forget things. In a second you forget.
Okay, 1 minute, sir.
Scroll down. Oh, both of them do not follow normal. Oh, that's a problem. Okay, fine. So anyway, so you can practice with this data. Fine. I'm not practicing you this sigma level computation. But these are the job to be done in your project, okay? Any questions? You can stop.
So this last data set, from where did we copy this?
In that TOH Excel,
Okay.
there is a page called process improvement. In this, there are two data. One is average, another is loss. So you can practice. So I keep it for your practice.